The Vought V-173. In 1942, residents of Connecticut began reporting disc-shaped objects in the sky. The object in question was the V-173, a wooden and fabric prototype built for the U.S. Navy, and it remains one of the strangest aircraft ever to fly successfully. The design came from engineer Charles Zimmerman, who had spent the 1930s developing a theory that a disc-shaped wing, combined with large propellers at the wingtips, rotating against the wingtip vortices, could produce exceptional lift with minimal drag. The Navy saw potential for a fighter that could operate from short carrier decks, and signed a development contract in May 1940. The first flight took place in November 1942, and after early problems with control forces and gearbox vibration were resolved, the aircraft's performance validated the theory. The V-173 could take off in under 200 feet, remain controllable at extremely low speeds, and test pilots found it nearly impossible to stall. Charles Lindbergh flew it and reported favorably on its handling. During one emergency landing on a beach, the aircraft flipped onto its back to avoid two civilians, and the airframe proved strong enough that both plane and pilot escaped serious damage. The Navy ultimately canceled the program in 1947, partly over cost and delays, but primarily because jet propulsion had made the concept obsolete. The sole surviving aircraft is displayed at the Frontiers of Flight Museum in Dallas. The Lockheed XFV. During the early Cold War, military planners fixated on a single scenario. What happens to air defense when every runway has been destroyed? Lockheed's answer was a fighter that rested nose up on its cruciform tail, launched vertically, transitioned to level flight, and then landed by backing itself down onto its tail while the pilot looked over his shoulder at the ground below. The aircraft was unofficially named the Salmon, after test pilot Herman Fish Salmon. The program's central failure was propulsion. The 7,100 horsepower Allison turboprop the design required was never delivered, and the interim engine could not lift the aircraft vertically at all. As a result, the XFV completed 32 flights using a temporary fixed landing gear, taking off and landing horizontally, which undermined the entire purpose of the design. Salmon did demonstrate that the concept worked in the air, transitioning to vertical flight and hovering at altitude. But the Navy's assessment was decisive. Landing a tail-sitter demanded a skill level that only the most experienced test pilots possessed, and the aircraft would have been slower than the fighters it was meant to intercept. The program was canceled in June 1955. The Airbus A300-600 ST Beluga. Well, that's a mouthful. Moving on. The Beluga exists because Airbus has a structural problem that no normal cargo aircraft could solve. The company manufactures its airliners in sections spread across Europe, and those sections, including entire wings and fuselage barrels, have to reach final assembly lines in Toulouse and Hamburg. For years, the job fell to a fleet of Super Guppies, converted 1940s Boeing Stratocruisers originally built for NASA, which led to the long-standing industry observation that every Airbus was delivered on the wings of a Boeing. By the early 1990s, the Guppies were aging and undersized, so Airbus modified its own A300, removing the upper fuselage and installing a cargo hold 7 meters in diameter and nearly 38 meters long, with the cockpit relocated below the cargo floor so the nose could swing open for loading. The A300-600 ST Beluga first flew in September 1994. Its payload of 47 tons is unremarkable, but its cargo volume exceeds that of a C-5 Galaxy because the aircraft was designed for bulk rather than weight. 5 were built, operating costs fell to roughly a third of what the Super Guppies had required, and the fleet remained in service for 3 decades before the larger Beluga XL succeeded it. The Snecma Coléoptère. In the 1950s France, engineers built an aircraft that looked like it belonged in a science fiction film. The Coléoptère was an experimental jet designed to take off and land vertically while standing on its tail, eliminating the need for a runway entirely. Instead of conventional wings, the fuselage was surrounded by a single annular wing, and the pilot sat in a tilting seat at the very top, lying on his back during vertical flight. The concept came from the same Cold War fear driving all vertical takeoff research. If runways were destroyed, fighters would need to launch from anywhere. Test pilot Auguste Morel completed 8 flights, reaching altitudes of around 800 meters. But the aircraft had a persistent tendency to rotate slowly on its own axis while hovering, and controlling it during descent was judged nearly impossible. On the 9th flight, in July 1959, Morel attempted the transition toward horizontal flight. The aircraft lost stability at low altitude, and he was forced to eject at just 150 meters. He survived with serious injuries. The Coléoptère was destroyed, and the program was never funded again. The Lackner HZ-1 Aerocycle. In the mid-1950s, the U.S. Army pursued an idea that sounds reasonable on paper, a personal flying machine so simple that any soldier could learn to operate it in 20 minutes. The result was the Aerocycle, a platform mounted above two contra-rotating rotors, with the pilot standing upright on top, secured by a safety harness, and controlling the aircraft through motorcycle-style handlebars. Early testing was promising enough that the Army ordered 12 units, envisioning a modern airborne cavalry for scouting and rapid movement across rough terrain. That optimism did not survive the test program. Captain Selmer Sunby, who took over flight testing at Fort Eustis in 1956, concluded that the Aerocycle was far too difficult and dangerous for an untrained infantryman to operate. The low-mounted rotors kicked up debris, the aircraft developed uncontrollable pitching at higher speeds, and on two separate occasions, the contra-rotating blades flexed into each other mid-flight and shattered, causing the aircraft to crash. Wind tunnel testing at Langley never determined why the blades kept colliding. The Army terminated the program, and a single surviving example is preserved at the U.S. Army Transportation Museum. The Lockheed Ring Wing. In the 1950s, Lockheed studied an airliner concept in which a single enormous circular wing wrapped around the entire fuselage, arching from the middle of the aircraft back to the tail. The engineering logic was genuine. A ring-shaped wing has no wingtips, which means no wingtip vortices, which in theory translates to more lift, shorter takeoff distances, and better fuel economy on short routes. Lockheed took the concept seriously enough to file a patent for an annular wing aircraft in 1959. But as engineers worked through the numbers, the concept fell apart. The ring generated enough additional drag to erase the fuel savings, and the structure had to withstand aerodynamic flutter that no practical design could solve at acceptable weight. The ring wing remained a paper study, which is precisely why it makes this list. It is one of the few radical designs where engineers recognized the fatal flaws before anyone had to discover them in the air.